Hey everyone, and welcome to this explainer. Today, we are unpacking a highly practical, incredibly important topic: secure network connections. Imagine being able to construct this impenetrable armored tunnel right through the absolute middle of a chaotic public space, allowing your most valuable assets to travel in complete secrecy. Well, that is exactly what we're going to look at today as we completely demystify site-to-site VPNs and how to implement them in PAN-OS. Think about the modern enterprise for a second. You've got your main headquarters, you've probably got multiple branch offices scattered all over the country, some data centers, and, of course, an ever-expanding footprint in the cloud. The fundamental challenge for network engineers is figuring out how to bridge the gap between all these distinct locations. You have to send highly sensitive data across the internet, which, let's be real, is a wild, completely untrusted public network. So how do you do that without exposing your data to everyone out there? Okay, let's dive into this. Here is our blueprint for today. We're going to cover the connectivity challenge, the IPsec secure tunnel, Phase 1 and Phase 2, a PAN-OS implementation guide, and finally, troubleshooting your VPN. Section 1. The connectivity challenge, bridging the gap between networks. So the definitive answer to our connectivity challenge is the site-to-site virtual private network, or VPN. Basically, it creates a highly secure encrypted tunnel between two distinct networks directly across a public network. Think of this tunnel as a custom suit of armor for your data packets. And the absolute biggest takeaway here: every single piece of traffic inside is heavily encrypted. Your data might be traveling across the crazy public internet, but to anyone trying to intercept it, they're not seeing anything useful at all.
Section 2. The IPsec secure tunnel, the mechanics of network armor.
For a VPN to actually function, it relies entirely on three foundational pillars. First up is Phase 1, which handles peer authentication and creates that initial secure channel. Second is Phase 2, which builds the actual data tunnel and defines exactly how your specific traffic is going to be protected. And the third pillar, which honestly is incredibly easy to overlook, is the firewall policy. You literally must have a rule allowing the traffic to pass. If even one of these pillars is missing or misconfigured, absolutely zero data is getting through that connection. Now, what's really interesting here is that IPsec isn't just one single thing. It's a whole suite of protocols. iKey handles all the key negotiations, but the real difference lies between ESP and AH. ESP, or Encapsulating Security Payload, is the heavy lifter. It provides encryption, integrity, and authentication. Because it actually encrypts the data, it's the protocol used in almost all real-world scenarios. AH, on the other hand, the authentication header, only provides authentication, no encryption whatsoever. That's exactly why AH is rarely, if ever, used in modern deployments. ESP is what provides the actual armor. Let's actually trace the journey of a data packet going through this ESP encapsulation process. It's pretty cool. First, your original sensitive data packet hits the firewall and is immediately encrypted, locked down. Once it's secured, the firewall slaps a brand new IP header onto the outside of this encrypted package so it knows where to go. Next, this armored, encapsulated packet is fired off across the chaotic public internet. It's totally safe, because anyone who intercepts it only sees that outer header and just a block of encrypted noise. Finally, the destination firewall catches it, strips off that outer encapsulation, decrypts the payload, and delivers your original packet completely unharmed to the destination network. Section 3. Phase 1 and Phase 2. Establishing trust and building the pipeline. I always like to think of IK Phase 1 as the super strict security guard at the front gate doing a thorough ID check, while Phase 2 is the construction crew that actually builds the pipeline. Phase 1 is all about establishing trust between the two firewall peers. It defines who the peer is, the authentication method, the encryption algorithms, and the diffie-Hellman group. Once, and only once, that trust is completely established, Phase 2 kicks in. Phase 2 builds the IPsec data tunnel itself, defines how the data will be encrypted, and crucially uses the proxy ID to dictate exactly which network subnets are even allowed to flow through this new pipeline. Zooming in on Phase 1 for a second, you've got a choice to make regarding how you actually prove your identity. The pre-shared key, or PSK, is basically a complex shared password agreed upon by both sides. It's a lot simpler to configure, making it a total favorite for standard, straightforward setups. Certificates, though, act as highly secure digital passports. They are undeniably way more complex to manage and deploy, but because of their incredible security and scalability, they are the absolute standard for large, enterprise-grade corporate environments. So the crucial point here, and I literally cannot stress this enough, the configurations on both sides of the VPN tunnel must match exactly. Your encryption algorithms, your Diffie-Hellman groups, your pre-shared keys, and your proxy IDs must be identical mirror images on both firewalls. If there is even a slight typo or a mismatched setting, Phase 1 or Phase 2 will instantly fail and your tunnel is never coming up. Compatibility is absolutely everything. Section 4, PAN-OS Implementation Guide. From Theory to Palo Alto Practice. Palo Alto's PAN-OS utilizes something called a route-based VPN. This is fundamentally different from older policy-based VPNs. In a route-based setup, the firewall's routing table is the boss. Traffic hits a standard routing rule, which then directs it to a virtual logical layer 3 tunnel interface. Once the traffic enters that tunnel interface, the firewall basically says, okay, I need to encrypt this, and forwards it out via IPsec. This means your routing decisions are just as critical as your encryption profiles. If you are ever building a VPN in PAN-OS, this right here is your golden checklist. Honestly, this is screenshot worthy. You're going to need the iKey crypto profile for your Phase 1 settings. From there, set up the iKey gateway to define the IP addresses and authentication. Then you'll configure your IPsec crypto profile for Phase 2 data protection. Don't forget to create that logical tunnel interface we just talked about. Next is the IPsec tunnel configuration object itself, which acts as the glue binding Phase 1 and Phase 2 together. And finally, you absolutely must configure a static route. And listen, this specific step is a total rite of passage for every network engineer out there. You can spend hours meticulously crafting the most mathematically perfect NSA-level encryption profiles for your Phase 1 and Phase 2. Both phases can be up, totally green, everything looks great. But if you forget the static route, your traffic will literally just stare at the tunnel and never go inside. Always, always remember to point your traffic into the tunnel interface. Now, as your network grows, your topologies are going to evolve from just a simple one-tunnel connection to a hub-and-spoke model, or even a highly complex full mesh, where every single site talks directly to every other site. To manage these complex setups at scale, PAN-OS offers tunnel monitoring. This lets the firewall actively ping across the tunnel to ensure it's actually alive. If that ping fails, the firewall can take automated action for you. It can wait, recover, and just hold on. It can fail over to an entirely different backup route, or it can accelerate recovery, which forcefully tears down and renegotiates the tunnel to quickly clear out any glitches. Section 5. Troubleshooting your VPN, the step-by-step diagnostic roadmap. And this brilliantly illustrates exactly how you should approach things when a VPN inevitably breaks. You got to do it logically and sequentially from the responder's side. Don't just guess. First, verify Phase 1. Are your PSKs, IPs, and crypto profiles identical? Next, verify Phase 2. Do the proxy IDs and algorithms match perfectly? Then, check your routing. Actually, scratch that. Routing is the biggest culprit. Have you actually routed the data to the tunnel? After that, check your security policy. Is there a rule letting the traffic pass? And finally, dive into the firewall logs and check the iKey info and tunnel info status screens. If you follow these steps in order, you're going to isolate the problem quickly and efficiently every single time. Well, we've covered the core concepts, the two phases of trust and transmission, the PAN-OS implementation specifics, and how to troubleshoot like a real pro. Ultimately, mastering these steps is just super empowering. It means you are no longer at the mercy of public network vulnerabilities. You own the security of your network's data, entirely and completely, regardless of where it travels in the world.
And that brings us to the end of our explainer. You have the blueprint, and you now know exactly how to build the armored tunnel. So I'll leave you with this question to ponder about your own infrastructure. Now that you have the ultimate secure pipeline, what data will you trust to travel through it next? Thanks so much for joining me, and keep learning.